Okay, today I'm going to review a recent paper I saw titled, or at least attempt to review, titled De Novo Design Voltage Gated Anion Channel Suppressed Neuron Firing. I'm going to provide a link in the description. Also, just a quick thing, if you guys like experience like an earthquake or hear a lot of things, it's my cat walking around. Yeah, so I'm sorry about that. But yeah, this paper explored the synthesis de novo, so from scratch, of a pentameric voltage gated ion channel. The pentameric just refers to a common conformation that we observe in nature of these channels. Okay, so this is a totally novel amino acid sequence. They ran it through BLAST to confirm that. These specific channels are tunable in comparison to the much more complex naturally occurring CLC1 and CLC2 channels, so the chlorine channels that naturally occur in biological membranes. So that's interesting. They can be tuned via amino acid substitutions, which this paper explored relatively extensively. One way that they used these substitutions was via patch clamping, so just measuring like the conductance through the channel. Okay, so the specific amino acid they really explored was arginine, positively charged in like living systems. So for example, they would substitute glycine for arginine, completely different properties, as we recall from biochem. Okay, so pretty much what this do is just increase the affinity for anions through the channel, specifically chlorine in this study, recalling that positively charges are attracted to each other. Also, I want to do a quick blanket statement to recall the significance of chlorine channels in the central nervous system, for example. It's often, or they are pretty much exclusively inhibitory when it comes to like GABA and glycine. Okay, remember that it's going to damp down the central nervous system and just pretty much depress it. Okay, and we see in conditions such as epilepsy and whatnot that we often see upregulation of the central nervous system, so this could potentially help combat that. And I apologize for any blatant ignorance because I haven't studied anything extensively yet. So I am excited to follow this literature in the future and see what happens when they progress to in vitro or in vivo studies. Okay, so let's take a few steps forward and examine R157, a specific amino acid in this dVGAC, this de novo synthesized voltage gated anion channel that confers these special properties. Okay, so R157 is critical for increasing the channel activity, and other positively charged residues are important for the unidirectional flow of anions. Okay, so I will post a few figures up on the screen somewhere to actually show what I'm referring to showcase the specific amino acids lining the pore through 3D modeling. Okay, and these figures demonstrate that the relationship between the number of arginine residues lining the pore is linear with the conductance, so the amount of current flowing through the channel. That said, some locations are more specific than others, and they demonstrated this through specific mutations. For example, going back to that specific R157, so the arginine amino acid 157, if we mutate that and replace it with glycine, okay, so completely different properties, remember, that will considerably decrease the conductance, and I'm going to show a figure of that showing that relationship. Okay, let me not forget to mention the actual purpose of the arginine residue. It's going to function as both a voltage sensor and confer ion selectivity. Okay, for some reason this specific ion channel showed remarkable selectivity for chlorine in comparison to like the other halogens, and I will also show another figure of that on the screen. Also, these channels exhibited a linear relationship between membrane potential and the influx of chlorine ions. Okay, so as we increase the membrane potential, as it becomes more positive, as it becomes more depolarized, chlorine ions will flow through. Okay, so another mutation they examined was arginine 161, replacing it with alanine. Okay, remember, different properties, and this actually removed the unidirectional flow, making it bidirectional. So yeah, and that's another fascinating thing that they uncovered about their de novo designed ion channels. Okay, and I would just comment that mutating any of these three residues will remarkably decrease the conductance. Now I'm just going to talk about some practicalities and just how it relates to naturally occurring channels. These channels show similar conductance to CLC1 and CLC2, once again the naturally occurring channels, modulated by GABA and glycine of the CNS and PNS. Okay, and what these researchers really emphasized was their capacity to develop these channels that are able to undergo conformational changes in response to voltage. In other words, their capacity to detect environmental stimuli, in addition to their physiological effects in situ, or in situ. Okay, likewise, though this is a bit esoteric, the topology that they examine in these channels is unique. It is an N-N-C out topology, whereas traditionally in nature we see the N inside the biological membrane as well as the C on the inside of the biological membrane. However, in these channels it is different. However, we do continue to see that conductance is still effective. Okay, so that just demonstrates that this NNCN topology is not necessary for expected conductance. Okay, so I just wanted to say that. Okay, so the last thing I want to touch on is the practical application of these channels. So as the paper mentions, this is a very endothermic process to actually insert these channels into the membrane, meaning that it just requires a lot of energy. So it's relatively impractical as of now, but I believe that they will circumvent this in the subsequent future. But yeah, that's pretty much it. I'm just gonna do a quick little recap real fast, so bear with me. Okay, so Zhao and their colleagues manufactured and examined these voltage-gated anion channels with the remarkable selectivity for chlorine, a halogen, and the method they used to examine the properties of this channel was various amino acid substitutions with the intention of observing differences in conductance. Okay, and these are expected to have prominent roles in modulating neuronal firing, which theoretically has the capacity to treat, probably not in my lifetime, neurological maladies, which is deeply fascinating. Oh my god! Okay, remember this is in its very early stages, and I'm just excited to follow this literature, see where this goes. But that's about it. That's all I really wanted to discuss in this video. Once again, I apologize if I misspoke or if I just seem ignorant, because I am ignorant. But that's the purpose of this, right? But yeah, thank you guys, and yeah.